Good morning everyone. I'm K. Theta from ECE Department in Srinivas Ramanujam Institute of Technology. Today I'm here to give a video presentation about the topic maxima and minima in two variables. Here we can learn about introduction, saddle point, working rule to find out maxima and minima of two variables, example and applications of maxima and minima. Now we should know the meaning of maxima and minima. First, these are the highest and lowest values of function which can be obtained by using its domain. Applications, it can be applied in optimization of engineering, physics and economics. Let f of x comma be a function of two variables x and y at x equals to a and y equals to b is said to have maximum or minimum values of f of a comma b greater than f of a plus h comma b plus k, or f of a comma b less than f of a plus h comma b plus k respectively, where h comma k are small values. Extreme values. F of a comma b is said to be an extreme value if it is either a maximum or minimum point. Now, saddle points. Before that, we should learn first about critical points. Critical point is a point which the derivative of the function becomes 0 or undefined. Now coming to stationary value, f of a comma b is said to be stationary value of f of x comma y if fx of a comma b equals to 0, fy of a comma b equals to 0. Every extreme value is a stationary value, but not every stationary value is an extreme value. It is also called as saddle point. Now the given graph represents saddle point. In this we can see local minimum, global minimum and saddle point. Now the working rule to find maxima or minima of f of x comma y. First, you should find the partial derivatives of the function with respect to both variables, like fx equals to dou f by dou x, fy equals to dou f by dou y. Now next, step 2, you should find the critical points by solving the equations and equating the partial derivatives to 0. Find the critical point, evaluate the second order partial derivatives in third step, like fxx equals to dou square f by dou x square, fyy equals to dou square f by dou y square, fxy equals to dou square f by dou x dou y. Compute the discriminant d at each critical point. Now d equals to fxx a comma b, fyy a comma b minus fxy a comma b whole square. The test for maxima or minima. In this step we can find the local minimum, local maximum, or if it has no solution, no solution. If d is greater than 0 and fxx a comma b greater than 0, then f has local minimum at a comma b. If d is greater than 0 and fxx a comma b is less than 0, then f has a local maximum at a comma b. If d is less than 0, then a comma b is a saddle point, which is neither a maximum or minimum. If d equals to 0, then it has no solution. Now let us see this. Now let us see the maxima and minima with the example. The example problem is f of x comma y equals to x power 4 plus y power 4 minus 2x square minus 2y square plus 4xy. Now solution given, we should write the above equation f of x comma y, and we should do the partial derivatives with respect to x and y. If we do partial derivative with respect to x, we get the equation 4x cube minus 4x plus 4y equals to 0, and with respect to y we get the equation 4y cube minus 4y plus 4x equals to 0. Now solving the two equations, we get x cube plus y cube equals to 0 and y equals to minus x. Now substitute y equals to minus x in equation 2. We get x equals to 0 and x equals to plus or minus root 2. These are the critical points. Now to find out saddle points, x equals to 0, y equals to 0, x equals to root 2, y equals to minus root 2, x equals to minus root 2, y equals to root 2. Now from one of the saddle point at 0, 0, we should find f of fxx, which is r. We can do fxx as r, so dou f square f by dou x square equals to 3x square minus 1. Now fyy, which is dou square f by dou y square, that is 3y square minus 1. Yes, dou x fxy, which is dou square f by dou x dou y, that is equals to 1. And from the determinant, which is rt minus s square, we should substitute 0, 0, then we get 0. If the determinant is 0, then it has no solution. At root 2, minus root 2, if we substitute the given points in the determinant, we get 24, which is greater than 0. So we should substitute the given points in fxx, that is r, which is 3x square minus 1. We get 5, which is greater than 0. If both determinant and r is greater than 0, then it has a local minimum point. So to find out the point, we should substitute the points into equation 1. We get minus 8. So it has local minimum at minus 8. Now at minus root 2, root 2. First we should substitute the given points into determinant. Then we get 24, which is greater than 0. Now we should take another fxx, which is 3x square minus 1. Then we get 5, which is greater than 0. If both greater than 0, which is determinant and t greater than 0, then we should substitute the given points into equation 1. We get minus 8, which is local minimum of the point. Now applications of maxima and minima. We can apply this maxima and minima in engineering design, which helps in maximizing strength, minimizing cost, in economics, profit and loss calculations, and in physics, equilibrium points in system. Thank you.